All right, today we're going to talk about higher order derivatives. The learning target is I can find more than one derivative for a function. We're going to also be learning some new notation to help us out with this. All right, since taking the derivative of a function results in another function, it is possible to take more than one derivative. You can take a first, second, third, and fourth derivatives, and even more than that. Recall, when we first introduced the derivative, I used the f prime notation, like here, or we use dy dx to represent the derivative. Usually we've been using dy dx when we've been doing implicit differentiation. We will need new notation for taking more than one derivative. I'm going to talk about that in the next slide. So here's the notation that we should know. The first derivative that we know already is the f prime notation, or dy dx. Now, the notation for the second derivative looks like this. You have f double prime of x, or you write this one, which means the second derivative. A lot of times we wonder, why is the squared with the d and why is the squared with the x down here? That is just a notation. So we don't have to worry about why this is the case. This is just notation, and all you have to know is what it means. All right, so this represents the second derivative. The third derivative, we do f triple prime, or again, we put a 3 next to the d on top, a 3 next to the x at the bottom for the third derivative using the this notation right here. So now the fourth derivative, so it's funny because you would think that they would keep going on with these right here, doing little apostrophes for your derivatives, but once they hit after 3, you can start writing a little 4 here. So this means the fourth derivative, or using this notation right here, d to the fourth y all over dx to the fourth means the fourth derivative. Then for fifth derivative, you're going to write a 5 and a 5 over here, and so on. So again, after you stop at 3, the prime notation you could change to a number afterward, just so that you know what does each of these mean when you see them. All right, so that's some notation. So let's go ahead and apply some examples. So let's see. The example 1 says find the first, second, and third derivative of this polynomial function. So the first derivative we all know, we're going to bring down the exponent, multiply, subtract 1, and then recall that a constant by itself is going to give us 0. So I know that plus 2 is going to give me 0 when I take my first derivative. Here's my first derivative. Great. All right. Now, to take my second derivative, you're just going to go ahead and take the derivative of the first derivative. So this is going to give us our second derivative. That's our second derivative. The 3 came down to give 60, minus 1 to give x squared. 2 came down to give you 18. 2 minus 1 gave me x. Derivative of 14x was just 14. Minus 9 was a constant. That disappeared. So that's my second derivative. And then the third derivative, you go ahead and take the derivative of the second derivative. You get 120x minus 18. So this is my first, second, and third derivative. All right, let's do another example using the other notation that you're expected to know. So find the first, second, and third derivative of the function f of x equals sine x. So the first derivative of f of x equals sine x we know is cosine. dy dx is cosine of x. The second derivative of cosine of x we know is negative sine x. The third derivative of negative sine x is going to be negative cosine x. And again, you can use your derivative sheet to look up the derivative of sine, but that's where this is coming from. This became negative because of this negative sign right here in the second derivative. In example 3, I want you to find f triple prime, or the third derivative of f of x equals 1 over x. So remember, whenever you have 1 all over some variable number, you always want to bring up the variable up into the numerator position by making its exponent negative, and then we can use the power rule. unless you want to go ahead and try to use quotient rule 3 times, which will make your life a little bit harder. So my first step is to remember, bring this up. That's going to make your life easier. You're going to be using the power rule if you do this. Good. So now I rewrote this to x to the -1. Now let's begin to take the derivative. The first derivative, you bring down -1. -1 minus 1 gave me -2. Awesome. That's my first derivative. My second derivative, we're going to bring down that -2 times -1 is +2. -2 minus 1 is -3. Good. And then my third derivative, which is right here. And then once you hit your third derivative, you could go ahead and rewrite this x to the -4 in the bottom to get -6 x to the 4th. There we go. So that is example 3. Just making sure you're keeping track of each derivative and the signs. Alright, so example 4 involves a chain rule problem. Now I know this is chain rule because we have an inner function, which I color-coded as green, and our outer function, which is to the x to the 3rd power. Alright, so we want to find the third derivative. So let's go ahead and begin the first derivative. So chain rule says take the derivative of the outer function first while keeping the inner the same times the derivative of the inner function. So that's what this looks like. I took the derivative of the outer function, so I brought the 3 down. 3 minus 1 is 2. And then the derivative of my inner function is 4. So that's where this came from. So then 3 and 4 is going to give us 12. Good. That's the first derivative. Now let's go on and find the second derivative. So we're going to be finding the derivative of this thing. The 12 in front of this function is just going to stay there. Only if a constant is by itself should it become 0. This 12 will not become 0 because it's in front of this function. So the 12 is just going to stay there. So we're going to bring down the 2, subtract 1, and then take the derivative of the inner function. Let's go ahead and do that. So I brought down the 2, I got 24. I kept the inside the same, 4x minus 5, and then the derivative of my inner function was 4. So this is chain rule. Great. Now let's simplify. 4 times 24. 96, and then this is to the first power. First power just becomes that. And then nicely, what we can do is distribute this. And I'm distributing because for the next step, when I take the third derivative, I don't want to use product rule. It's easier for me to use power rule. So I'm going to distribute this in to get 384x minus 480. Good. So now I could take the third derivative much easily because you'll see that my third derivative, this is going to become 0, and this is just going to be the slope, which is 384. That is my third derivative. It's interesting because the third derivative is just a constant. So I believe that is the end of our examples. So we're going to move on to the task that you have at hand. Good luck. Let me know. Raise your hand if you have any further questions.